Hi guys, BuildZoid here, and today we're going to be taking a look at a very silly motherboard, the Gigabyte Z690 Aorus Xtreme, which was provided to me by Gigabyte, so thank you Gigabyte. And I said this board is very silly because it's $900, and there's two ways to describe this board. One, an overpriced Z690 Aorus Master, and two, an overpriced Gigabyte Z690 Aero D. Because that's basically what this is. It takes some of the features of the Aero D, and it combines them with some of the features of the Z6 of the Aorus Master, and smashes them together, and then doubles the price basically. Because the Master is a $470 board, while this is $900, right? So it's basically double the price of the Master. I'm not sure what the price of the Aero D is. If the Aero D is like $430, which it might be, that wouldn't be a totally ridiculous price for that board. If the Aero D is $430, then this board is literally the combined price of an Aero D and a Master. which I think would just be kind of funny if that actually ended up happening. That this is exactly what you would pay if you just bought both of those. And technically, it does a little, and in some ways, this board is slightly worse than either of those, depending on what you're looking for. So let's go around and take a look at the feature set. So of course, we've got a postcode over here with this fancy like metal aesthetics cover. We've got this plastic tab thing for hiding your 24-pin power connector. Honestly, I don't like it very much. Not because it's plastic, but like the way it attaches, it's just like, I don't know. I think I would have preferred to just have the 24-pin visible. Then again, I've come to realize that my taste, like my taste in aesthetics is very different from most people. Like I really miss the days of having the colorful like motherboards, the MSI like Dragon chipsets. Those were fun. But yeah, and now everything is black and boring. Anyway, so you get your postcode, power button, reset button, 24-pin, like right angle 24-pin, ATX board, EATX board, very EATX board. So watch out for like where that 24-pin is going to end up, because actually don't watch out, just don't buy this board. Buy yourself a sensible motherboard instead, and then you don't have to worry about case compatibility. It's not like you're going to be losing out on much. Anyway, so that's actually kind of all you get for like internal functionality. I don't even think this board has voltage read points unless they're hiding under this. But if they are hiding under that, the fact that this is such a pain to remove is all you need to know about how overclocker friendly this is. So even if there are voltage read points under that, that doesn't count. It's just like, no, you can't put them under that. Like, I'm not gonna, like, if people want to use those voltage read points, assuming that there are any there, I'm pretty sure there aren't. But if there were, it's like, you have just, no, like, that does not count, because I'd need to, like, at that point, I may as well just stab one of the tantalum capacitors. That's actually going to be easier. Not super accurate, but much easier. Anyway, so that's the sort of internal, like, overclocking stuff, not really much there. Then you get 4 M.2 slots, one of them connected directly to the CPU, and that's Gen 4, and then you get these 3, which are also Gen 4, and those are connected to the chipset. Now, for comparison, the Z690 Aorus Master actually has 5 M.2 slots, 4 of which are connected to the chipset. This board is even bigger than the Master is, and yet it only has 4 M.2 slots, which I'm a little bit confused about, because, like, the board is physically larger. There should be space, right? But apparently there wasn't, so you only get 4. So other than that, you get X16. So you get X16, X0, or X8 down here. So you do get 2 PCIe slots connected directly to the CPU, which is nice. I'm a big fan of having that function on motherboards, because PCIe lanes are old. Like, you can convert PCIe lanes into whatever you want. You want some crazy fast, like, enterprise grade SSD in your the second X8 slot, knock yourself out. You can do that. You want a RAID controller, or like some crazy networking card, or just a real, like, maybe some kind of capture card, whatever. You can connect it into a PCIe slot, and so obviously X8 gives you plenty of bandwidth to play with. Potentially you can, depending on if the BIOS supports it, you can even get like PCIe to M.2 cards that'll let you go for like 2 more M.2 drives. So personally, I'm a big fan of having the dual X8 support. However, Gigabyte has a motherboard that's much cheaper that has dual X8 support, It's called the Aero D, right? So this is one of those functions that like the Aero D does this for like half the price. So if this is why you want this board, you could just get that instead for half the price and, you know, spend the extra money on things that actually make your computer go faster, like a better cooling system or something, or better memory kits, or a better GPU, or like anything else. Anything else, right? Money you don't spend on your motherboard can go into things that actually matter. And anyway, so yeah, you get the dual X8 support, which, you know, it's a cool feature, but at this price point, like there's so many other motherboards that do this for so much less that I don't really like at it would be offensive if this wasn't here at this price point is the way I see that. So that's not optional. That's not like a nice extra at this point. That is like if this board didn't do that, you know, that would be a problem. Anyway, let's take a look at the rear I/O. Gigabyte managed to cram an absolute ton of USB Type A ports in here. So that's neat. Like the very clear, you know, my effect on Gigabyte motherboard design can be very clearly seen, I think. So yeah, you get 10 USB Type A's, you get Thunderbolt, but no display pass-through, which is like, I don't know how many people actually use display pass-through with Thunderbolt. I've never actually had a Thunderbolt anything. But yeah, this board doesn't have display pass-through for Thunderbolt. So if you were planning to like hook up your monitor to the Thunderbolt ports, good luck with that. It might do the iGPU, but you won't be able to pass your main GPU into that. And what's surprising is like I can get why they didn't put like a DisplayPort input on the rear I/O, but in the past, we've seen motherboards from like ASRock where you'd just get like a DisplayPort hanging out internally. So you would just take a DisplayPort cable and, you know, run it through a PCIe slot in the back of your case and then feed it back into the motherboard internally. Which admittedly is not very aesthetically pleasing, but it would get you display pass-through. So I'm kind of surprised that they didn't do that. Admittedly, they'd also have to like tweak the VRM heatsink design to actually get that to like fit. But anyway, so yeah, you do get Thunderbolt 4, but you don't get display pass-through for it. You get 2.5 gig Intel LAN, 10 gig Intel LAN, which you get this again on the Aero D. And actually, you also get Thunderbolt 4 on the Aero D for significantly less. And there's also the Asus ProArt motherboard, which has both Thunderbolt ports with display pass-through. The Aero D does one display pass-through, the ProArt does two of them. So yeah, that's something to consider. Like, if you want actual like Thunderbolt for monitors, then I don't think this board is actually capable of doing that. Then for audio, you get your optical, and then line out and mic in. Wi-Fi 6E from Intel, of course. Then you've got the OC ignition button, which this basically just keeps your power supply turned on. Very useful if you're doing extreme overclocking. I have no idea why it's on such a normie motherboard. And, you know, somebody might be like, how is this a normie motherboard? Do you see any voltage read points on this? Because I don't, so it's a normie motherboard. Anyway, so yeah, I'm not sure why this is on such a normie board. I've heard people say that they use this for filling their water cooling loop, which to me is insanity because this holds your power supply on, which means you have 12 volts going into your 8 pins. And 12 volts going into your GPU, and 12 volts going basically everywhere 12 volts normally goes. Right? Because all the OC ignition button does, it prevents the actual like power, like the VRMs from turning on. But the 12 volts that goes into those VRMs is still there. And when you have a like water cooling leak, the rail that does the most damage is 12 volts shorting to other stuff. So if you like, I don't get it, because if I was filling my water cooling loop, even if I had leak tested it, I would have, you know, I'd fill it using a jumper, okay, on the power supply with everything unplugged, because like I don't know why you'd want to be running power into your components while filling the loop. Like I see no good reason to do that, unless I guess maybe your loop is like incredibly tightly like integrated with the power cables, so like you can't like unplug everything or something. But yeah, no, I do not get why you would want to use this. But it's there, and if you have a use for it outside of extreme overclocking, good for you. I don't know why you'd want to use that. And next to that, we get the Q Flash Plus button, which allows you to update the BIOS of the motherboard without even having a CPU installed. So that can also sometimes recover from bricked BIOS flashes. So anyway, let's talk about the power delivery. First, it's worth noting that like most high-end motherboards, actually, I think even the low-end Z690s regularly get two dual 8-pin power connectors. You don't need to plug in both of these. You only need to plug in this one because like your 12900K is not going to pull enough power to max out a single 8-pin unless you're doing if you really hammer the CPU, you'll be able to max out the 8-pin. But like I've only ever gotten I've not managed to get above 400 watts of power going into the board. So, and each of these power connectors is good for over 400, assuming that your power supply isn't trash. So you don't need to plug in both of these. Like you really don't. Anyway, let's talk about the actual VRM. So for the VRM, this is like, and this is the part that's like really like, oh yeah, this is an overpriced Z690 Master because the VRM is basically the same, much more expensive, but basically the same. So what's going on with this? So you've got a 20-phase V-core, and those are 20 feet, like they're 20 real phases, 20-phase V-core. And then you get one phase for your iGPU, and I should put that over here. One phase for the iGPU, right? And then down over here, you have your 2-phase VCC in. And so what's going on with this in terms of controllers? Well, it's very simple. We've got a Renesas RAA a 229131 voltage controller, which is a 20-phase voltage controller. It's the latest and greatest from Renesas. And they've maxed it out. Like that's all they've done is just they went and took all 20 phases from the 229131 and shoved them all into V-core. Now this leads to a funny issue of how do you power the iGPU if your main voltage controller has run out of phases? Well, you add another controller. But the part I don't get, actually no, I do get it. This is a $900 motherboard, so the cost of, you know, some high-end 20-phase voltage controller from Renesas is completely irrelevant because it's a $900 motherboard. So you get another RAA 229131 running in +1 mode. Or more like one-phase mode. It's not even +1. It's just one phase off of it, right? Because the plus is normally to indicate like multiple outputs on the same controller. No. This is running 1 + 0. That's right. A 20-phase controller being used to run a single-phase iGPU rail because the board is $900 and cost, you know, like cost optimization went right out the window. Funnily enough, they do not give you a 100 amp smart power stage on the iGPU rail though. They did cost optimize the power stage selection a little bit, but not the controller. The controller just uses another RAA 229131. I guess it does simplify things that, you know, they're already ordering a bunch of these, but it's just so weird. Especially, and yeah, it's just so weird to see such a like monster of a voltage controller handling one phase. Anyway, let's talk about the power stages, shall we? Oh, I guess I should have also talked about VCCN. So VCCN, very simple. It's the same thing we've seen on all the other Gigabyte motherboards I've covered. It's an MP2940 2-phase voltage controller from Monolithic Power Systems. And yeah, so that's what's controlling the VCCN. Now then, let's talk about the power stages. And it's worth remembering that the Gigabyte Z690 Aorus Master has a 19-phase V-core with +1 on the iGPU, where all of it is handled by one controller instead of two separate ones. So anyway, what are the power stages here? Well, Renesas doesn't currently make anything better than the RAA 220105. So yeah, that's what you get. You get a 220105. And that is a 105 amp smart power stage. And this right here is a nominal current figure. Technically speaking, yes, you can run 105 amps through this smart power stage under very, very specific operating conditions. More realistically, you shouldn't even be pushing more than like 40 amps through one of these because they're going to produce a hell of a lot of heat at that point. So anyway, smart power stages are called smart power stages because they integrate a whole bunch of current like monitoring functionality as well as safety features. So they do temperature monitoring, current monitoring, overcurrent protection, over temperature protection, short circuit protection, and a whole bunch of other, safety features that we're not really going to get into. And that's why they're called smart, because normally you'd have to implement all of those extra functions with external components, which you don't need because you've got these fancy 105 amp smart power stages, which are very expensive. So we've got 20 of those making up the vCore VRM, which for comparison, the Z690 Aorus Master has 19 of these. Yes. So, and this is the part I'm kind of annoyed about. So I copy paste, like the way I do my notes for these videos is I just copy paste a past motherboard, and then I just, fill in all the different, like refill in all the different sections. So I did that for this board, right? I took the script for the Z690 Aorus Master because that's the most similar motherboard to this board. And I deleted all of the calculations that I did for the Master, and I redid them. And they worked out exactly the same, because I don't go to like decimal precision. There's a bit of rounding in the heat output for the smart power stages and the inductors, right? That's which I guess I should mention that. Smart power stage plus inductor, which I'm just going to use choke for this. What the hell is that? Choke. Yeah, so that's inductor, just another term for inductor. So anyway, yeah, so for the smart power stage plus inductor heat output, and yeah, I recalculated everything for this board, and it's the same values as the Master because I don't go into that much precision, and this is 20 phases of the same parts that the Master uses 19. Surprise, surprise, adding one more power stage to the VRM really doesn't make much of a difference, especially when you already have 19 of them, right? Like if you were going from a single phase to a two phase, big difference. Literally doubling the current handling capacity. Going from a two phase to a three phase, still a big difference, right? You're going to be getting like 50% more current handling capacity, assuming that the thermals are ideal. And then you go from like three phase to four phase, so on, right? And then you go from 19 to 20, and the diminishing returns are so diminished that you can't even, like, with the accuracy that I'm calculating to, it's just, no. It's not even there. So anyway, at 1.2 volts output voltage and 500 kilohertz switching frequency, 200 amps at 200 amps output current, the power stages and inductors of this board should be producing about 15 watts of heat, which is exactly the same as the Z690 Aorus Master. It is very low. That is a very high efficiency. Like it's so low that you can run this VRM without a heatsink, which is also true for the Z690 Aorus Master. It also helps that both this and the Master use an 8-layer PCB, so like, this is the thing. It's the same damn board as far as I'm concerned. Like, the VRM is the same. Anyway, 300 amps output. We've got the same 22 watts of heat output that you would from the Master. 400 amps, you get the same 31 watts that you'd get out of the Master, roughly, right? Again, roughly 31, but the same thing. Like, 500 amps output, you'd get about 40 watts of heat output. And 600 amps output, you get about 55 watts of heat output. Now, 12th gen CPUs run, like maxed out, run between 200 and 300 amps. So basically, this is massive overkill. And that's all you really need to know. It's the same level of massive overkill that you get on the Master. Actually, it's one power stage more overkill than what you get on the Master. Or about, I think it's like 5%. Something like that, right? Going from 19 to 20, that's going to be roughly 5%. So yeah, basically it doesn't make a difference. It's going to run, like, you might be able to measure that this runs slightly cooler because there's like one more power stage across which the heat is spread, but yeah, this just does not, like, I don't get it. Like, I don't get why they did this. I don't know why they bothered. At all. Just, they could have left it as a 19 phase. Then again, it's a $900 motherboard, so quite frankly, who cares? It's like, it's not like this board was going to be cost effective if it had one less phase. It's not like it would have suddenly been $700 instead of $900, so, at $700, I still think it would be yeah, that would still be a really high price for the board, but better than 900, but no, it's $900, and so quite frankly, does this VRM make any sense compared to the Master? No. Does it need to make any sense? No, because the price already doesn't make any sense. So, Anyway, they did make one major well, it's not really a major adjustment. They did make some other adjustments to the VRM. They added more of these tantalum polymer capacitors to improve the transient response a bit. And when I say a bit, I mean I have doubts about this actually functionally making a difference. The socket capacitor configuration is the standard, Gigabyte mix of multilayer ceramics and tantalums that you get on all of their higher-end LGA 1700 motherboards. Like the Aorus Pro has that, and that's a $330 board, so that's nothing new for Gigabyte there. The bulk aluminum, like the through-hole capacitors, are just aluminum polymers from Nichicon, and those are 10,000 hours rated, 10,000 hours at 105 degrees Celsius FP caps. The bulk capacitors for input filtering, there's only 6 of them, which is kind of funny because the Aorus Pro has 8. And I'm still not sure why that board, like it's specifically that board. That board has 8. And every other board I have from Gigabyte so far has 6. And all of the boards and all the other boards I have from Gigabyte so far are more expensive. So I'm really confused as to why that is. Admittedly, the more expensive boards do have more phases. So, well, no, because going from 16 phases to 19 phases, the input ripple, like, again, diminishing returns, like it's not. Yeah, no, I'm not sure why that board gets more input filtering capacitors, but it shouldn't really make much of a difference, or any difference. But yeah, that's the thing is once you get into the super ridiculous, once you get into the super ridiculously expensive motherboards, past a certain point, it's like you might be lucky to measure a difference. Anyway, on the front of the board for filtering, we obviously have multi-layer ceramics in the actual socket because on this side of the board, the impedance to the actual pins in the socket is really low, so you want to use your multi-layer ceramics on the top, and the tantalums on the back. Like, you wouldn't want to put the tantalum capacitors on the top side of the motherboard because the multi-layer ceramics actually are better off being up here, whereas the tantalums can do a perfectly good job from the back of the socket. Anyway, the two-phase VCC in is the same two-phase VCC in we've seen on every other Gigabyte Z690 motherboard so far. So the power stages are the MP79992s. These are 70 amp smart power stages, and Gigabyte is this VCC in is very, overkill for what you need. Most Z690 motherboards will actually ditch the second phase, or a lot. I'm not sure that most, but a lot of Z690 motherboards don't bother with that second phase, and they use the exact same power stages and controller as Gigabyte does. And so it's kind of surprising that they opted to have two 70 amp smart power stages instead of just one, because this rail, it's outputting 1.8 volts because it's for feeding the integrated voltage regulator of the CPU. And so it really doesn't need to push much current because it's pushing such a high voltage that you don't need a high current to deliver a lot of power, right? Like, the high current part of the power delivery, that's handled by the CPU's own internal voltage regulator. That's the whole point of that, right? That's the whole reason Intel came up with the integrated voltage regulators was especially for their server CPUs, it was well, trying to shove 300 amps into a CPU at 0.8 volts, very difficult. Very, very difficult. So it would be much better if we could shove 1.8 volts into the CPU at I don't know, 150, significantly lower current, and then convert that into the really high current at the actual CPU. Much less losses in the power plane of the motherboard, that kind of thing. So it's better power delivery. So it's kind of weird that they only use it for VCCN on Alder Lake, but yeah, for Alder Lake, VCCN is handled by the is used for just minor voltage rails inside the CPU. Anyway, so that's the power delivery of this board, and it's basically the same as the master. That's a bit of an understatement. It does have, a few more tantalums, but for the most part, it's the same as the master. Also, the master is also an 8-layer PCB. This is also an 8-layer PCB. Speaking of PCB layers, let's talk about the memory topology. It's the standard, shielded daisy chain, which I guess I should have put that at the top. Shielded daisy chain topology, and this is the norm for Z690 motherboards right now. I've not seen any other topologies on any of the motherboards so far, and so obviously you want to use these two DIMM slots first because though each of those DIMM slots is at the end of the daisy chain. And if you use like this DIMM slot instead of this DIMM slot, what basically happens when you have a fast signal traveling towards the memory stick, that signal will actually sort of carry on past the memory stick and then reflect off the end of like the second DIMM slot. And so that's really bad and causes a bunch of interference. And then that's why if you put your DIMMs into the wrong slots on a daisy chain motherboard, you get actually, like, you're lucky if it boots. It's basically what you end up with. It's not a problem if you have 4 memory sticks at the same time, because each memory stick has its own termination. So, then you don't have to worry about it. And the only thing the memory controller has to deal with is that it has to account for the fact that some signals arrive sooner than others because one stick is physically closer to the memory controller than the other stick. But anyway, shielded daisy chains right now are the norm for Z690 motherboards, and this one is obviously implemented on an 8-layer PCB, which with Gigabyte does seem to give a very slight advantage in terms of memory overclocking. Compared to their 6-layer topologies. It's not a huge difference, but, a couple hundred megabits per second. So, yeah. We find it for comparison on DDR4, basically the 6-layer board versus 8-layer board didn't matter. So, yeah. It's kind of interesting to see that with DDR5, this is starting to become significant. At the same time, DDR5 runs way faster than DDR4 did. So anyway, that's the memory topology. We've talked about the VRM, covered all the different features the board has, and yeah, like, it's a overpriced Z690 Aorus Master or an overpriced Z690 Aero D, depending on how you look at it. If you want Thunderbolt and you want 2.5 gig LAN and 10 gig LAN, it's an overpriced Aero D. Also, if you want the dual X8 support, right, it's an overpriced Aero D. The Aero D does all of those things. That's actually one of the reasons why I'm super interested in that board. Is that it does dual XA, it's got the 10 gig, it's got the, well, I don't actually care about the Thunderbolt personally, I just like the Aero D for the dual XA, but, it does have some extra features, like other interesting features for other people out there, like the 10 gig and the Thunderbolt and that kind of thing. And so, this is kind of like if you took the power delivery of a Master and combined it with the feature set of the Aero D, but it's twice the price of either of those, so it's like, why? Right? Like, honestly, you could buy, well, actually, no, you couldn't buy a Master and, well, no, you could buy a Master, buy a Thunderbolt add-in card, and come out ahead in terms of how much it cost you to do that. Which is kind of the issue once you get into these super ridiculously expensive motherboards, is just like, which admittedly, you don't get the dual X8 PCIe slots, and there's really no cheap way to do that. I think for servers, there's something that does like splits PCIe lanes, but it is very expensive if I remember correctly. So that's not really an option. But yeah, if you just wanted like the Thunderbolt, you could just get a Master, which already has 10 gig, right? Like that already has 10 gig. So then you just need to add the Thunderbolt, and you've got basically the same features that you get here. So this board really doesn't make any sense. Oh, I guess I didn't talk about the VRM heatsink. But the VRM heatsink really doesn't matter. Also, the audio is all attached to the VRM heatsink. So I guess it does matter in the sense that, like, if you try to run the board without the VRM heatsink, you won't have audio because it's part of the VRM heatsink. I'm not sure if they did this to, like, get better audio isolation. Because obviously on most motherboards you have this, like, there's like an isolation slot cut into the, it's not really cut into the motherboard, but you have the isolation line indicating where the ground plane is split for the board to basically basically block noise from the rest of the motherboard getting into the audio section. Well, with this approach, you don't really need to worry about that because the audio section is not part of the board anymore. It's its own little board. I don't know if this actually has any major benefits. It's just kind of there. So, yeah. I have no idea why they did that. It might be just to accommodate all the USB ports, right? Because normally you'd have the audio outputs over here. Then again, I feel like they could have just made these stacks 4 tall, right? Because this is only 4 ports anyway. So, yeah, no idea why they put the audio separately. And then, so that's what they did with the VRM heatsink. Obviously, they're syncing the inductors now, also the power stages. This heatsink is a massive pain to get on and off the board, by the way, because it's like everything's one big chunk. Also, there's your 10 gig LAN cooling. because the 10 gig chips can get a bit hot. And then here's the front of the heatsink, and obviously we have the very dense fin stack, which ideally works best in forced airflow environments. Luckily, it's completely irrelevant when your VRM is mega as overkill as it is on here. So, you could literally the funny thing is if you tried to run this board without the VRM heatsink, the thing you'd have to worry about is this chip over here. Which, actually, I wonder if you could get away with that. Oh, no, you couldn't, because, yeah, because you'd only have 2 points of mounting for the 10 gig heatsink. Because you can see how the 10 gig heatsink is actually like a separate piece of metal from the rest of the VRM heatsink. But, yeah, if you tried to pull that off, it would only have 2 support points. You'd probably have to put like a rubber bumper or something here so that it doesn't short the board. Well, it's anodized aluminum. It probably wouldn't short anything, but it might crush some components if it, flops around badly. So yeah, you would want to, secure that somehow. Yeah, so honestly, the 10 gig is the part that needs this heatsink more than the everything else on the board. So yeah, anyway, that is it for real this time for the Z690 Aorus Xtreme. Its price tag is certainly extreme. It's the thing is they've put basically everything this board does on a master or the Aero D. So I do not get this board at all. If you buy this board, I do not get what went through your head when you made the decision to buy this motherboard. Because you could have you could probably just buy an Aero D. Well, admittedly, you couldn't put them together. And the Aero D does have a weaker VRM than this, but the thing is, I don't think it would be for daily overclocking. I don't believe you would be able to notice or maybe even measure the difference. Because that was already an issue I had with Z490 motherboards, was the voltage regulation was so good, even on the low-end Gigabyte boards, that compared to the high-end boards, they were getting the same results. And since then, Gigabyte has basically, across the board, they've upgraded to the Renesas RAA 229131. The tantalums are still there in the back of the CPU socket. Now, not all of the boards have the extra ones, scattered around the front of the board, but on Z490, those didn't really make a difference. So I can't imagine that on Z690, it'll be much of it, they'll suddenly start to matter again. But I will be doing a little bit of testing, because if I'm only testing Gigabyte boards against Gigabyte boards, I can actually do that without having to physically modify a CPU to get accurate measurements, because the boards are going to be consistent in their layout to some extent. So yeah. Anyway, Z690 Aorus Xtreme, $900 of, I don't know, yeah. Thanks, Gigabyte, for providing the motherboard for the video, and I'll probably do some... Actually, I probably won't, because the Master is just more convenient to run on a test bench anyway. It doesn't have the silly angled 24-pin. That's actually kind of obnoxious, because my 24-pin cable is used to plugging into the motherboards normally, not from the side. And so, anyway, doesn't matter. Yeah, thank you, Gigabyte, for providing the board. Thank you for watching the video. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, hoodies. There's zipper hoodies now. You'll have to scroll all the way to the bottom of the store page, because I haven't reorganized the store page for a while. But yeah, they're zipper hoodies, and they're pretty cool. So if you'd like to support the channel, Patreon and Teespring help out immensely with that. And yeah, that's it for the video. Thanks for watching, and goodbye.